Hello and welcome to the video. This is the first video in a series of videos that I'm going to create so that I can walk you through a workflow in Delmia Robot Programmer. So to get started from the very beginning, what happens is, because this is a cloud-based server, so this is hosted remotely, and you will receive an invitation to come to the server. So we recommend Google Chrome as one of the supported browsers that you can use. And using Google Chrome, when you navigate to the platform, it will show you the name of your platform, and it'll also show you how many members there are. It'll show you things like how many roles are available that you can grant to people. Once you receive this, under My Platform, you can navigate to the applications. So these are the roles that I have granted to me. So I have a collaborative designer for SolidWorks, and I have robot programmer. And so robot programmer is the role that I'm going to talk about today. And these are all of the applications that are available inside of robot programmer. This application is called Robot Programming Essentials, and this is the application that we're going to be mainly dealing with. You may wish to drag the applications under My Favorites. It makes your life a lot easier and it'll save you a lot of time. So once you navigate to the Robot Programming Essentials application, there's a down arrow next to it, and it will show you, if your software has been installed, it will show you what level of software is installed. If it's not installed, it will offer you an opportunity to have the application installed. And it will ask you if you want only this one application installed, or if you want all of the granted applications installed. So you can select which one. I recommend having all the applications installed. And then once they're installed, you'll be able to launch the application once it's installed. You also have the opportunity to install the optional content. And what the optional content is basically, this is the robot library. So in other words, when you go to where the software is installed inside of a file browser, here is the content for this version of software. And here's the robot library. So here's where you will find all of the robot models that you can import into your platform. I'm going to double click on the application to get it started. So here's the application as it first appears. And you'll see that there are different menus depending upon which types of functions you want to use. You'll also notice that there's an immersive browser which contains different views of data. You can look at manufacturing views, you can look at simulation states, you can look at the clash and invoke clash, you can look at results of studies, and you can look at behaviors of devices. We'll get all into this later. Okay, so let's talk about the settings for a couple of minutes. So first is the spaces. Common space is a collaborative space in the database. And so this comes in by default. And this is like a division of the database where everyone has permission to read and write on data. Also, there can be other spaces allocated. So you could have a private space that you can use as your own sandbox and perform your own experiments or exercises or training or whatever have you, and it keeps the data separate from the other spaces. The other thing is preferences. So setting up the software to use it, there's a few things you should be aware of, and the first one is the profile. You might not be used to working the mouse inside a 3D experience. If you're more accustomed to something like SolidWorks or maybe CATIA, you can change the properties of the mouse by changing the profile. And once you change the profile, you do have to restart the software, but the mouse will behave differently. So when you're changing the viewpoints in 3D Experience, we use a middle mouse plus a right mouse button and a combination of those, where in SolidWorks, it's different. You're using keyboard buttons. So you can set this up to your preference. The other thing I want to talk about is navigation. If you are using the 3D Experience mode, typically because we're building work cells, we want to keep the floor on the bottom so that we don't come up with goofy views of things, like coming up from the floor, for example. I turn on the gravitational effects on Z because this tends to keep the floor on the bottom. So as you navigate with the mouse and change your views, it tends to hold the ground on the bottom, and so it helps with your viewpoints. Here we can add new content or we can import things. So importing data into the database. New content adds content into your PPR tree. And then you can open new types of files like a product, empty product, empty part, empty drawing. And this is where we can save data or share data or export if you have the capability to do that in your permissions and settings. And this is about the 3D Experience platform, and this will tell you what you have installed as far as versions, etc. And so when you hit function F3, you will see that there is a tree on the side, and a lot like inside of SolidWorks, this tree is going to list everything that we have loaded in our session. And in Delmia Robotics and in Delmia roles for digital manufacturing, we call this a PPR tree because it's going to contain the product, the process, and the resources. So what I'm going to do is I'm going to just open up a new window and start fresh. Okay, and I'm going to introduce some new content in here. The first thing I want to do is I want to be able to organize underneath a work cell or a facility. So I'm going to start with a manufacturing cell. In this manufacturing cell, again, I'll hit function F3. This is going to represent my work cell. Okay, so next I want to populate this tree with components. One of the components I want to bring in is a robot. So after installing the optional content, I can navigate to it on my hard drive under import, and I could bring it into my database. So here's my build content inside my robot lab. And so I can look for a specific robot. So there's the robot manufacturer, Nachi. Here's the controllers that are supported. I want something from the AX. And let's try the ST200. This is a duplication string, and this will precede any names that are in the tree. So I'm just going to delete it, and I'm going to import it as new. And as you can see, it was imported successfully. And this is a navigation view. of this robot. So what I really want to do is to open this, but I want to open all of it. So I'm going to say open advanced. And whenever we open in Delmia Robotics, we open advanced because we do want math data be loaded on certain components, and the software will know which ones we need the math data for based on how we have them grouped. And so what I want to do is I want to open my data with the expanded children and with all the representations so that I don't miss anything. And here's my model. And it already has the kinematics built into it. So as you can see, I can jog it around. So I can also search for it in the database. So here is the product data, and the rest are the pieces that make it up. Okay, so getting back to my work cell, if I want to populate this work cell, I want to insert components into it. So I'm going to exit the 3D simulation mode so that I can start to bring in some components. Okay, so what I'm going to do is I'm going to insert an existing resource into my station. And it wants to know what is it you're looking for. So I want to find my Nachi robot, and I could do multi-selection if I want to pick more than one thing to insert at the same time, which is very handy. So once I find it in the database, I can now bring it in. Okay, so that's one way that you can bring in components. And there are all sorts of different ways that this can be done. You could have two sessions open and copy and paste from one tab to the next tab. Or I could use the Bookmarks browser. But first, we need to address how do you create something in the Bookmarks browser? So let's change gears and take a look at that. So inside my applications, there's a bookmark editor. And this is a widget-based application where you can start to build bookmarks of your equipment. So you bring in your equipment from SolidWorks onto the 3D Experience platform, and then you start making bookmarks. And all a bookmark is like a catalog of resources and things that you would use for your robot work cell. You could have models of robot controllers or pieces of fences that you could assemble into an enclosed area. You can have grippers and different types of robots. So let's take a look at how we create this. So I'm going to click on the highest node, and when I right click, I'll create a new bookmark. And I'll call this manufacturing resources. So this is my new book called Manufacturing Resources. When I click on it, add existing would mean that I could search for something in the database and add it into here right now. Or I could upload a file into this chapter. But first I'm going to make some sub-chapters here first. So I'm going to right click and I'm going to say a new bookmark. And let's call this one Robots. So I'll click on Robots, and inside of Robots, I want to add another bookmark. And this one would be called Nachi. So this is where I will house my Nachi robots. So inside of the Nachi chapter, I will be able to add an existing. Now I say OK. Once I find my robot, I click on OK. And so now I have a component inside of manufacturing resources under robots under Nachi. And so when I want to use this robot inside of my work cell, okay, so now if I want to insert something from that bookmark that I just created under tools, I can find the bookmarks function, and it will show me all of my bookmarks and all the books that I marked. So under bookmarks, there's my manufacturing resources. Here's robots. I'll double click on Nachi, and here is my ST200. So I can just take this, click on it, and then I'm going to grab it and drag it, and I'm going to drop it in my station. Okay, so now I have two robots in exactly the same spot in my work cell. So how do I move them? This is called the robot compass. And so I'm going to use this to move a component. And I'm going to do that by double clicking on it, and it will show me where it is located in the world. Now I'm going to right click on it, and I'm going to tell it to snap automatically to whatever I select. So now the compass is actually attached to whatever I pick. So when I pick a robot, it's attached to it. So I can now drag it, rotate it any way I want to. And I can locate my components using this. I can also use this panel to rotate in any increments that I want to, or translate it in whatever increment that I need to. Or if I know exactly where I need it to be in the world, I can simply type in that location and hit apply. Okay, so now that we know the basics, let's get started and just start from the beginning and build a work cell. So I have myself an empty session, and I'm going to start out with new content, and this is going to be my manufacturing cell. So I'm in my session. I'm in Robot Programming Essentials. That's my app. Here is my manufacturing cell. When I use function F3, I can now modify the properties and give it a name that's meaningful. Okay, so now I'm going to start populating my work cell with the objects that I placed under my bookmarks. And to do that, I'm going to leave 3D simulation. 3D simulation is more of a math-based kinematics and motion with time added kind of an environment. So it's not really required for layout. And so when doing the layout of a work cell and positioning components, what we'll want to do is exit our 3D simulation world. And so this is our static environment, and this is where we want to do a lot of our layout. It just makes it easier. So I click on Tools, and I'm going to use my bookmarks. And I'm going to populate my work cell here. So I've made several different catalogs. This one, called Production Resources, is the most populated with objects, because I've put things in here, like I put a robot controller in here, and I've put some fence pieces in here, and I have a gripper, and I have several different robot models that we can use. So the first thing, I'll start with the tool base, and I just put in a relatively large one. So I'll click on that tool base, then I'll left click and drag it. One of the neat things about the 3D Experience platform is the fact that you can do a lot of dragging and dropping. You can go from a tab to a tab and drag and drop. Sometimes you can go from the web browser to a session and drag and drop from there. So in other words, if I had my Bookmarks editor open inside of my web browser, I could grab something from the web browser and drag it into this window and drop it. So here's my tool base. I'm going to put in a couple of tables. There's one. I don't think I grabbed it. Okay, so now I have two tables. So if you remember from earlier, I right-click on the compass and I say, snap automatically to the selected objects. So now I can take my tables and I can locate them. Now, because I've already done this before, I know that one of these tables is going to be for a pickup, one's going to be for a drop-off, and the other one's going to be for a robot stand. Okay. Let's find a robot. I'm going to use this Fanuc M20. It's going to be doing my arc welding. Okay, so I want to rotate this 180 degrees, and you see how it snapped every 90. And that's because of the settings. When I double click on the compass, I have all my increments at 90, so I will only see 90 degrees. If I wanted something different, like 45, I have to change it to 45, and now I can get something different. If I'm not quite certain what I need, a lot of the times I'll just make this 1, and that'll work for most purposes. But it does require some skill with the mouse, because you're reading off of this call out that gives you the angle. The other thing is, if I notice it's not square with the world, I can input a value and then hit apply. I know something's wrong if I see something in here like 33.3. I know that that's incorrect, and I'll just take the closest value, 0 to 0 or 90 or 180, 270, 360, and then that will give me a corrected position. There we go. At this point, I can put in fencing if I want to. But be aware that when you're working on a robot cell and you're doing all this zooming and panning and you're looking at different objects at different angles from left and right and up and down, realize that when you do have fencing in your work cell, it's going to get in the way. It's going to present a problem with you finding the viewpoint that you actually want. It's going to interrupt your viewpoint, so to speak. So I tend to leave the fences for later. If I just put them in here, I can position them, but the purpose that they serve is to identify the area and also to complete my resource bill of material. So, you can put them in earlier, but you might wind up just changing the visibility of the object because it gets in the way. See, so if I had some fencing in here and I want to zoom in on something on the robot, I got a piece of fence in the way, so we might not want to do that. I'll hit Control Z and it's gone. Okay, so I have a torch in here that I can use to put on the end of the robot. And it's another resource. Okay, so there's my torch. So I have almost everything I need to start welding except for the product. What I'm going to be working with. So I'm going to insert some new content again. And so this is going to be my manufacturing product. And the manufacturing product is a bucket that's going to hold whatever it is I'm. Okay, so I'm going to now insert a manufacturing product, and this is because the software needs to know what the product is, because when I start looking at the data that's contained in my product model, like if I want to lay out a arc welding path on it, for example, it needs the math data. So when I place my product data inside of a manufacturing product, it basically is telling the software that I do want the math data loaded along with it. And it knows specifically that it's not a resource, that it is a product. So I'm going to leave 3D simulation. Okay, so if I want to insert something inside of my work cell, so I want to insert something into this tree. Now, when I started with nothing and I had a completely empty tab, I used new content. And then I picked what type of content it was, and this became my starting point. Okay, empty. Now that I'm working with a tree already in place, I need to add to this tree, so I'm going to use a different function. So outside of 3D simulation, I'm not in 3D simulation right now. I'm going to use, and this is really just insert a data type into a tree kind of a function. And so I could insert a manufacturing cell into this manufacturing cell, and I would have a cell inside of a cell. So this could be like a subsystem of an existing system. Or I could insert a manufacturing product. Okay, so this is my empty manufacturing product, and now I want to insert an existing product into this product. So to insert inside of this product, I'm going to search the database for my product data. So I have a control arm with a jig, and these are both modeled in the same location. In other words, the control arm is inside of the jig, and they're both co-located correctly. And that's what I want. Sometimes it's difficult to place a piece of product that you're manufacturing into a tool base. It can be done, but it's kind of a lengthy process, and that's where you need the help of your designer. If you get both models with the same origin point, then one is located inside the other one, and you won't have to do it inside of Delmia. So I click on what I want to put into my manufacturing product. I have multi-select turned on here, and I'm going to hit that green check. Okay, so inside of my manufacturing product is my control arm and my jig. Okay. Okay, so using the compass is one way to do it. Now, if you see, this has been modeled with the origin skewed from the world. And so this is what I'm talking about when you have your design engineers and they are designing the fixtures and the products. You will want them to give you a good origin. Otherwise, you have to deal with it to make it straight. So let's try this. This is probably somewhere around 15 degrees. Okay. So there's the placement of my product. Perfect. So the next thing I want to do is go back into 3D simulation, and let's see about getting this arc welding torch onto the robot. I'm going to use function F3 again. And so this arc welding torch already has a couple components modeled in it that we'll show you later. One is a base port and one is a tool center point port. The base port tells us on what location should this torch be mounted with, and the other one shows us where's the tool tip, where's the actual welding point on this tool, which happens to be up here. So when I have modeled those components, what that means is I can easily operate this and use a function to mount it onto the robot. Under Motion Controller, there's a function called Set Tool. This is really a simple function to use, but it's very powerful because what it does is it puts the tool on the end of the robot, and it also defines it in a kinematic chain. For example, if this was a gripper, I would be able to tell it that it has an external axis that is being controlled by the robot. In this case, it doesn't. It's just a torch. So what I'm going to do is I'm just going to rotate this, and that's rotating in increments as defined here. And that looks about perfect for me. So I'm going to say OK. And what that did was mount the torch to the robot and defined a tool point. What that means is that I can now jog this when I'm in 3D simulation. I can teach the robot or jog the robot, depending upon which I prefer to use. Here's my singularity warning, and the robot arm is straight out. So yes, of course it's in singularity. We know that. Now remember, my setting is at 90 degrees again. Not good for programming a robot. So we're just going to change this to 1, close it out. Now, what I'll do is I'll just manually take joint 5. And crack it. There we go. Yes, robots are very particular about singularity. So let's talk about singularity just for a minute here. So singularity is when you have the wrist completely straight out. And what it does is it tells us that the robot has multiple solutions for a position that you're trying to establish. It's ambiguous. And so when that happens, you get a warning that tells you that the robot's in singularity. So as a rule, when you're programming a robot, you should always stay away from singularity because the robot cannot calculate its way out of it because, again, the solutions are ambiguous and it can't compute. And when it does not compute, it is not a good thing. So, see, I have these other manipulators to jog the robot with. So I could grab it, joint 4, joint 5, joint 6. And I can manipulate the robot like this. Okay, so this is for manipulating the joints. Another way to do it is this jog panel. So the jog panel tells you what the values are of the individual joints. So I don't care about configs and turns right now. So I can grab this and I can use the forward kinematics to jog the robot like this. And it shows me the value and the percentage of the joint used before the axis is maxed out. Here, let's get rid of this. Okay, so let's get a defined home position for this robot. Okay. So something that's out of the way. Okay, so before I start simulating, I'm just going to define this home position. It's not the type I wanted. So I'm going to define a tag target for this location. So this is where the robot's going to return to at the beginning and the end of each weld cycle. Home positions are always a joint move. And so this is the beginning and the end of the cycle. So I want to define this as the beginning point. I also want to define that the beginning point is with the the product located in the tool fixture in front of the robot. Okay, so now I need to define the location of everything as the starting point for my simulation. Okay, so now what we want to do is we want to lock everything into this position. And so to do that, I'm going to create what's called a simulation state. Simulation state can be any part of the process that needs to be defined. In other words, the robot's at home, the part has not been welded yet, and the part is located in the welding fixture at the right location for the robot to weld it. So I want to lock this down. And I want to say for all the objects, and I'll say OK. OK, now where did it go? Let's talk about the immersive browser. So under the immersive browser, here we see our states, and this is the state that we just made. And so I can recall this at any time. In other words, I can program the robot and move it somewhere. Anywhere, it doesn't really matter. And now when I go back to the state and I hit apply, it goes back the way it was. And so every time the simulation is run, it will reference this because it's set as active. This will be the state that the simulation will assume when I hit the run button, okay? Now, how do we know the simulation is going to assume this state? I can have different states. I can have a whole list of them and store different types of starting points in the work cell. In other words, I can have a state where if a part's being picked up, I can have the part in the pickup, or if the part gets dropped off by a robot and then gets welded, I could have a state where the part is in the welding fixture. So there's all sorts of different applications for the states, but how do I know which state would be applied? So looking in the browser, when you right-click on the state, you can do all sorts of different operations on these states, okay? So this is currently set as active because realistically it's the only one here. So I can unset it, and if you notice that green check mark in the corner went away. When this is set as active, what that means is when I create a robot program and I want to simulate it by hitting this run button, it reverts to this state, okay, because this is set as active. All right, so another thing that's important to know about states is that it doesn't just include the position of the robot. It also includes the position of the objects in the work cell and their color. So I can save different states and have different conditions applied and then invoke them to have the work cell assume that state or that condition. So in other words, if you notice, I have these gray, for example. If I apply a state, they're blue now, and the viewpoint changed. That's because what I did was I changed that state by applying a color. So in other words, if I go into my properties on this and I tell it no color, and I say okay, and now I create a new state, this would be called state 2. When you look at your advanced settings, selected objects only, all objects. So I prefer all objects because it could be the position of a tool, a position of the robot, the physical position or the orientation of the wrist on the robot. It could be the color. There's lots of things that get captured in a state. So when I say okay to this, and I hit apply on the first state, I see this. But when I hit apply on the state that I just made, different viewpoint, different colors. And remember, it also applies to the position of an object. So if I take the robot and I move it over here, and then I create a new state about it, so now, if I apply the first state, I can apply the second state, and I can apply the last state. And this is important because if you have things in your work cell and you like what you have, in other words, you've arranged the furniture and you have a good home position and the colors are agreeable with you and you like it, capture the state. Because if you happen to accidentally move something into the wrong position somewhere, and you don't know how to get it back exactly where it was before, you can always come up to a state and say apply, and it will resume that condition or that state of your work cell. So it's a really handy tool, and it's very important to use, especially when you're simulating.